All right, here's your homework for exponential growth and decay. Aaron owns a rare baseball card. He bought the card for $7.50 in 1987, and its value increases by 6% each year. Write and use an exponential growth function to find the baseball card's value in 2015. So if it's an exponential growth function, it's going to follow this form, where A is the initial amount. So let's start there. So the initial amount he bought it for was $7.50. R is the rate it's increasing by, which is 6% each year, but we need to write that as a decimal. And then T is how many years. So in this example, I need to go 1987 to 2015. How many years is that when you go from there to there? So we have 15 years in 2000 and 13 years before that. So 15 and 13, what was that? 28 years. So really what I'm doing is I'm plugging in 28 and then use my calculator. So if we type this into a calculator, the answer is $38.34, rounding. Jennifer started working at her job. She earns $6.25 per hour. Every 6 months, she gets a 3.25% raise. If Jennifer has worked at the job for 14 years, what is her hourly rate? So again, this is that growth model. It's increasing. Her original amount is $6.25. It increases at 3.25%. So that's 0.0325. We need to have that skill to move the decimal to the left twice. And then we have to understand this. Every 6 months she gets a raise for 14 years. So how many times are you calculating that? Every 6 months for 14 years, how many times did that go up? So twice a year for 14 years. So 14 times 2, that's where 28 comes from. And then put that in your calculator, and you can see she now earns $15.30 per hour. In 2005, Somerville Journal had 110 subscriptions, 10,000. The number of subscriptions decreased by 8% each year. Write and use an exponential decay function to find the number of subscriptions in 2020. So this one is decreasing. So decreasing is the similar, but instead of adding, it's subtracting. So in this example, the initial amount is 110,000. The rate that it's decreasing by is 8%. So we need to write that as a decimal. That's 0.08. And then T is the number of years. So we started at what year? 2005 to 2022. So how many years has gone by? That's 17 years. And that's it. Use your calculator, type it in carefully. And we need to round to a whole number. You can't have a decimal subscription. So it's 2,655 subscriptions. Number 4. In November, 26 students at high school had contracted the flu. Each month, the number of students who have contracted the flu increases by 36%. So there's the indicator in terms of what type of function you're using. So it's a growth one. So again, what did we start with? 26. It's increasing by 36% as a decimal. And then write and use it to see who have contracted the flu by May. So every month it goes up by that. So what month did we start with? November. So from November to May, how many months is that? So if you count it out, that's 6 months, December, all the way to May. 6 months. So there's 6. Use your calculator. Again, we need a whole number. You can't have a decimal student. So how many students? And the answer is 165 students. Ian bought a new truck for $35,000 in 2015. Each year the value of the truck depreciates. That means it goes down in value by 9%. Write and use, in this case, a decay function to find the value of the truck at the end of his 60-month loan. All right, so the initial amount is $35,000. It goes down by 9%. That's that 0.09, as 9% as a decimal. 2015, 60-month loan. So 60 months, I need to first of all equate that to years. So 12 months in a year, that's the same as 5 years. So I'm going to use 5 for t and then use my calculator. And then when you put it in, this one you don't have to round to a whole number. But for money's sake, two numbers after the decimal, and the truck will be worth $21,841.13. A certain compound has a half-life of 4 days. Write and use an exponential decay function to find the amount of compound remaining from a 75-ounce sample after 3 weeks. So, what did we start with? 75 ounces. It's decaying. Now, half-life means it's losing half of its, it's losing 50%, half of its size, and it's using that. So it has a half-life of 4 days. So what is it after 3 weeks? So this, we have to understand 3 weeks in terms of days, or the other way around. Days in terms of weeks. So we know that 3 weeks is equal to 21 days. So if I want to put t in terms of days, I'd put 21 days, but we're only putting it after what? 3 weeks. So we're going to use 21 divided by, here, make sure I'm doing it correctly. So if it's 4 days, we're going to write the formula as t divided by 4. And then 21 days we're going to put up there. So if it was 3 days, we put t divided by 3. Or 2 days, we put t divided by 2. All right, use your calculator. And you get 1.97 ounces. Turn the page. A 4-foot tree was planted in 1984. The tree grows continuously, 22% each year from this point forward. Find the height of the tree after 8 years. So the tree started out as 4 feet tall. 1 plus 22% as a decimal. And then from 1984, 8 years would just simply be 8. Use your calculator. Oh, it's continuously growing or decaying. All right. So for continuous growth, we use E for our base. So for E for our base, we start with the amount, E, then we put down the percent as a decimal, and then how many years. And that's it. So this follows when it's continuous growth, we often say the word PERT, P times E to the RT. Now use your calculator, and it's approximately 23.25 feet. Number 8, ice sculpture measures 52 inches and melts continuously. That's a big word. That means E is the base. It started with 52 inches. 3% per minute. That's 0.03. And then find the height of the sculpture after 15 minutes. So then I plug in that using that formula. So that's 33.16 inches. Sam shaved his head down to ½ an inch for a swim meet. If his hair grows continually at a rate of 1/4, so the key word is continually, that's E as the base. It started with 1/2 inch. It's growing at a rate of 1/4 of an inch per month. Find the length after 1 year. So 12 months in a year. And now use your calculator. Logistic growth. So the population of a fish pond from 2001 to 2014 is modeled below, where T is the years since 2001. Using that function, find the number of fish in the pond in 2014. So how many years have gone by from 1 to 14? Subtract 13 years. So plug in 13. Use your calculator. Now make sure when you use your calculator you put parentheses around the denominator, or else it will not work. So this one's a little more challenging, so I'll show you what it looks like on the calculator. So on the calculator, if I wanted to type that in, I go 1,125 divided by, and then I go parentheses 1 plus 12 E to the negative point. Make sure that negative is the little negative on the bottom, not the subtract sign. So negative 0.17 times 13. And then close it for the exponent, and then close it for the denominator, and then go. And then you can have your answer. So we're rounding it. Can't have 0.6 fish, so it's 486 fish. All right, last one, the bell rings. Someone's going to be coming in here in a second. So the bears in Alaska are limited to this, to a certain area, and so on. After 2 years, there's the logistic growth model, 17 years. So again, what number would you plug in to see how many bears? So plug in 17. Use your calculator, and you would get 91 bears. All right. Good job doing your math. That says bears. With me, good job doing your homework. Mr. G Math. Over now.